Welcome to all. For this video also, I am going to discuss about Unit 4 Hydrogen. Today topic Physical and Chemical Properties of Water. Water. Water is the chemical substance with the chemical formula H2O. The major part of the earth is covered with water. We need water for almost everything. For example, drinking, bathing, cooking, etc. So we should know about the property of water. 65% human body is composed of water. Water is essential for the survival of life on earth. Water is distributed unevenly on the earth's surface. It forms a major solvent and dissolve almost every polar solute. So let us go to study its property and understand the reason for its significance. Water is a colorless and tasteless liquid. Water is formed when two hydrogen atoms bond to the one oxygen atom. Water is not symmetrical. Electrons in water molecule are near the oxygen atom and less near the hydrogen atom. Water molecule is polar in nature. So, there is a greater concentration of electrons around the nucleus of the oxygen than around the hydrogen. Therefore, the hydrogen end is slightly positive and the oxygen end is slightly negative. So, water is a dipolar in nature. When water molecule attract to one another, the hydrogen end of one molecule is attract to the oxygen end of the another. So, hydrogen bond is formed between the water molecules. The molecules of water have extensive hydrogen bond resulting in unusual property in the condensed form. This is also lead to high melting and boiling point. As compared to other liquids, water has a high specific heat, thermal conductivity, surface tension, dipole moment, etc. These properties form the reason for its significance in the biosphere. Water is the only substance found on earth in the all three states. Water is present liquid state, solid state and also gaseous state. Water molecules are constantly moving. When temperature is increase in movement. Normally, water interact with other polar compounds. It is repelled by non-polar compounds. Small size allow it to separate areas, can convey other substances in solutions. So, water can dissolve more things than any other natural substance. It is known as universal solvent. Yes, water is called as universal solvent. Next topic, chemical properties of water. Water react with a lot of substances to form different compounds. Now we are going to discuss some significant reactions. First property is amphoteric in nature. Water can act as both acid and base, which means that it is amphoteric in nature. It has the ability to accept as well as donate proton and hence it can act as an acid or a base. For example, acidic behavior. In aqueous solution of ammonia act as a base, acquiring hydrogen ion from water molecule to yield ammonium and hydroxide ion. For this reaction, water is act as a acid. Basic behavior. When hydrochloric acid dissolved in water, that is produce H plus ions in solution. So here water is act as a base in nature. Redox reactions. Electropositive elements reduce water to hydrogen molecule. Thus, water is a great source of hydrogen. During the process of photosynthesis, water is oxidized to oxygen. As water can be oxidized and reduced, it is very useful in redox reaction. Next chemical property, reaction with group 1 metals. Group 1 metals, otherwise known as alkali metals. Alkali metals normally highly reactive. So, highly reactive alkali metals reacted with water to produce hydrogen gas, leaving an alkali solution. For example, sodium metal reacted with water to produce NaOH solution. At the same time, hydrogen gas is evolved. Next chemical property, reaction with group 2 metals. Hydrogen react with group 2 metals except beryllium to produce hydrogen gas. For example, barium react with water to produce barium hydroxide and hydrogen gas. Reaction with nonmetals. In the elemental form, nonmetals, for example carbon, sulfur and phosphorus, does not react with water, but in the compounds of nonmetals react with water to give acid or alkaline solution. For example, solution of carbonates or produce slightly alkaline solution. Reaction with halogens. Halogens reacted with water to produce acidic solutions. For example, chlorine react with water to produce hydrochloric acid and hypochlorous acid. It is responsible for the antibacterial action of chlorine water, so it is used as a bleaching agent. But fluorine react differently to liberate oxygen from water. Hydrolysis reaction. Water dissolve inorganic compound as well as some of the covalent compounds. For example, silicon tetrachloride, phosphorus pentoxide also easily dissolved in water. Finally, conclusion. Chemical formula of water is H2O. Molar mass 18.015 gram per mole. Odor, odorless. Density in the solid state 0.9167 gram per ml at 0 degree Celsius. Liquid state 0.961893 gram per ml at 95 degrees Celsius. At 25 degrees Celsius, density of liquid water is 0.99704 gram per ml. At 0 degrees Celsius, density of liquid is 0.9998 gram per ml. Boiling point 99.98 degree Celsius. Melting point 0 degree Celsius. Solubility: poorly soluble in aliphatic and aromatic hydrocarbons, miscible with acrylonitrile, dimethyl sulfoxide, dimethoxyethane, etc. Partially miscible with bromine, ethyl acetate, diethyl ether, dichloromethane. Acidity: pKa value is 13.995. Vapor pressure 3.1690 kilopascal or 0.031276 atmospheric pressure. Basicity pKb value 13.995. Refractive index value 1.3330 at 20 degrees Celsius. Thermal conductivity value 0.6065. Viscosity value 0.890. Crystal structure hexagonal in nature. Molecular shape bend shape. Dipole moment value 1.8546 D. Specific heat capacity. Specific heat capacity means the heat absorbed by 1 kilogram of substance to rise its temperature by 1 Kelvin at a specified temperature. Specific heat capacity means the heat absorbed by 1 kilogram of a substance to rise its temperature by 1 Kelvin at a specified temperature. Specific heat capacity value of water is 75.375 joule per mole Kelvin. Standard enthalpy of formation, that is defined as the formation of 1 mole of the substance from its constituent elements with all substance in their standard state. Standard enthalpy of formation is the formation of 1 mole of the substance from its constituent element with all substance in their standard state. Standard enthalpy of formation of water is minus 285.83 kilojoule per mole. Standard molar entropy, that means the entropy of a 1 mole of any substance at 298 Kelvin and 1 bar pressure. Standard molar entropy means the entropy of a 1 mole of any substance at 298 Kelvin and 1 bar pressure. Standard molar entropy of water molecule is 69.95 joule per mole Kelvin. Thank you.